Now there is another concept, another phenomena which is called as gravitational lensing. And gravitational lensing phenomena also is very similar to what is behind gravitational waves. So what we discussed for gravitational waves is that whenever you have a very highly energetic process or something that can distort space-time will create gravitational waves. Now whenever space-time is distorted, at this point of time there is something else that is created, and this is something which is called as gravitational lensing. The image that you see on the screen, a ring-like structure that you see, this is called as Einstein's ring. And the very photograph that you see is one of the most perfect Einstein's ring that has ever been observed by the scientists. This happened back in 2016. Now Einstein's ring is a phenomena which is associated with gravitational lensing. It is something which is created due to gravitational lensing. So let's first try to understand what is the meaning of gravitational lensing, and then we'll come back to what is the meaning of Einstein's ring. So first of all, if you look at this definition, this is how we define gravitational lensing. A gravitational lens can occur when a huge amount of matter creates a gravitational field that distorts and magnifies the light from distant galaxies that are behind it, but in the same line of sight. What do we mean? We simply mean that when you have a large cluster of galaxies, then what it means is that with this galaxy you would have a large amount of mass associated, and if it's a cluster of galaxy, of course it's huge, it's massive, and because of that again we see that space-time will be distorted. Now when you talk about light and how light travels with space-time. For example, if you look at the first image that you have on the screen here, light will just follow the lines like this. You can see that it will just connect the dots and it will keep on moving. But whenever you have something which is very massive, like when we are talking about the cluster of galaxies or even a galaxy on its own, then in that case what happens is that this space-time will be distorted. Whenever something very massive, whenever a celestial body also which is very massive, a very massive star for example, so in that case what happens is that space-time will be distorted. And with this distortion, the light is also just following the dots, correct? So because the light is just following the dots, it will also get distorted. The path of the light will also get distorted around this object. So instead of now following a straight line, it is now following a curved path. This is what happens with gravitational lensing. For example, if you look at this particular image, you have this image here where what you see is that you have a distant galaxy which is like this. At the same time you are observing it from the earth. Now when you are observing this galaxy from the earth, if there was nothing in between, then in that case the light would directly reach the earth. From this distant galaxy, the light will directly reach the earth. But because there is something in the way, because for example here we have taken a quasar, that there is a quasar in the way. In a similar manner there could be a galaxy in the way. So if there is something like that, it means that it is highly massive, and because if it is massive, what happens is that path of light will be distorted. Path of light will be distorted around this object, around this celestial body or a cluster of celestial bodies. So because of that, what happens is that light is reaching from here also, and light is reaching from here as well. From both the things, from both the points, we are seeing that light reaches the earth instead of reaching the earth in a straight line. So because of that, what happens is, if you look at here, there will be two images that will be produced. There would be two images. For example, you can see that there is one image like this, and there is another image that has been produced here. So instead of we seeing one image of this cluster of galaxies or a galaxy, we are looking at two images. These two images because of the distortion of path of light that happened. So this is called as gravitational lensing. Also the fact that because of this object that you have in the path, we also see that this light gets magnified and you see kind of a brighter light than usual. So this also gives us a hint that instead of looking at one single object, we are looking at actually the phenomena of gravitational lensing around that object. Sometimes there could be multiple images, not only 2 or 3 images, but rather a multiple set of images that can be created. And this is when there is a possibility that Einstein's ring gets created. So what we are looking at is something like this, right? The actual star's path would have gone like this, right? Somewhere here you might have observed it if you were here. But on the earth you are observing the star here. You are observing the star here. Why? Because there was was a distortion in the path that happened. But when you go and retrace the path, in that case, we'll observe the star to be here at this point instead of observing the actual star which was at this point. So this is happening why? This is happening because of the distortion in the path of light that has been created. So just understand this phenomena, that what is happening with gravitational lensing. So that's why coming back to the concept of Einstein's ring, what you observe as a kind of a ring-like structure is nothing but gravitational lensing that has happened, and because of gravitational lensing, multiple images of something has been created. And this multiple image that has been created, a set of images that have been created, this appears as a ring because it's all around that central object, and that's why this phenomena has been named as Einstein's ring. Now why Einstein is required here again? Because Einstein was the first person who had actually given the theory that distortion of space-time is possible. That there is a possibility of distortion of space-time whenever you have something which is very energetic, very violent, or very massive. And this was there in his general theory of relativity. And that's why when we observed this phenomena of gravitational lensing and the multiple set of images that are created due to gravitational lensing, we named it as Einstein's ring. Gravitational lensing, the phenomena of distortion of path of light that is created because of a massive object being there in the path of light. That distortion is called as gravitational lensing, and because of gravitational lensing, the multiple images that are produced, if they form a kind of circular or ring-like structure, then in that case we call it as Einstein's ring. I'm hoping that I am clear here. Look at this question. This had appeared in 2019 prelims paper. Recently, scientists observed the merger of giant black holes billions of light years away from the Earth. What is the significance of this observation? Look, this was a current affairs news, right? And this was something that was there in December 2018 edition of the Indian Express. There are possibilities that you have not read this news article. Even if you haven't, just look at the words, the keywords, the key phrases that you have in this question. Scientists observed merger of giant black holes. Merger of giant black holes, billions of light years away from the Earth. What is the significance of this observation? What will happen due to merger of black holes? Gravitational waves, one of the options could be there. First option, Higgs boson particles were detected. Nothing to do with Higgs boson. Gravitational waves were detected. Okay. Possibility. Possibility of intergalactic space travel through wormhole was confirmed. Nothing to do with wormhole. This is more of science fiction. Can't be the answer. It enabled scientists to understand singularity. Singularity is more associated with black holes. One single black hole, the phenomena of black hole. When we are talking about merger or collision of giant black holes, only possibility that exists is gravitational waves were detected. Simple question. Just if you have understood the concepts, if you know what these key phrases are, even if you don't know the current affairs, even if you did not go through this news article, still you will be able to answer this question. So that's why conceptual understanding in these kind of concepts become very, very important.